In this example, we're going to be finding exact values of trig functions. And we're given some information here. We know that cosine of theta is equal to a negative 2/3, and we also know that our theta value is between pi over 2 and pi. So let's go ahead and start working with that information first. Right, this is going to be an angle measure that is in quadrant 2. If you would rather work with degrees, pi over 2 is the same thing as 90 degrees. And pi is the same thing as 180 degrees. Right, so our angle measure has to be somewhere between 90 and 180. That's going to put it in quadrant 2. And you want to make sure that you're drawing your triangle in the correct quadrant. So let's go ahead and draw the triangle in quadrant 2. And you want to go ahead and connect your side down to your x-axis. So there's my right triangle. And I'm going to go ahead and put my theta value right here in this corner. And now we can go ahead and label our sides. So we were given some information here. They told us that cosine of theta was a negative 2/3. So remember that this is information about your adjacent side and your hypotenuse. If your trig function happens to be negative, just go ahead and put the negative sign either with your adjacent side or with your opposite side. Make sure that your hypotenuse stays positive in these examples. Right? And you want to make sure you include that negative sign when you're drawing your triangle as well. So my adjacent side is going to be negative 2. My hypotenuse is going to be 3. Right? And we still need to figure out the length of our opposite side. So let's go ahead and use Pythagorean theorem. We've got a squared plus b squared equals c squared. When I square my negative 2, that's going to give me a positive 4. And 3 squared is going to give me 9. So I can subtract my 4 from both sides. So a squared is going to give me 5. And now I can go ahead and take the square root of both sides. And for my a value, I'm going to end up with a radical 5. Now, keep in mind when you take the square root, you get both a positive and a negative number. You want to pick the one that applies to the situation that you're working with. Since you're working with a side length here that is on the positive y-axis, you want to make sure then that you use a positive radical 5 for this side length. Now that we have all 3 of our sides labeled, let's go ahead and find, we want exact values here, right, the exact value of each of the remaining trig functions. So for sine of theta, you're just going to be reading this information off of your triangle as you have it drawn, right? You need your opposite side over your hypotenuse, which in this case is going to be radical 5. Over 3. We already have information about cosine of theta, right? This information was given to us in the problem. We know it's a negative 2/3. Tangent of theta is going to be our opposite side over the adjacent side. So we have radical 5 over a negative 2. And then we can go ahead and find each of the other 3 trig functions. We have cosecant of theta. I'm going to go ahead and use my reciprocal of my sine function. So 3 over radical 5 And if you want to go ahead and rationalize your denominator, the other way to write this answer would be 3 radical 5 over 5. Secant of theta is my reciprocal of my cosine function, so a negative 3/2. And my last one, cotangent of theta. I need to take my reciprocal of my tangent function. That's going to give me a negative 2 over radical 5. If you want to go ahead and rationalize this, negative 2 radical 5 over 5 would be an okay answer as well. Now let's just recap a couple pieces of information here. Make sure when you're writing your trig functions that you have your theta values on each of your trig functions. There's no such thing as sine of nothing. You have to have an angle measure there. So double check your work, make sure you have it written down. And then let's go ahead and take a look at our answers in relation to where the triangle was drawn. Right? Keep in mind, when we were working with our trig functions, all of our trig functions are positive here in quadrant 1. In quadrant 2, our sine functions are positive. In quadrant 3, that's where our tangent function is positive. And in quadrant 4, our cosine function is positive. Now notice that we drew our triangle in quadrant 2 based on the information that we had. So if you're taking a look at your answers, your sine function and anything related to sine, which would be in this case cosecant, should be positive. Right, so if I take a look at these two pieces of information, my sine and my cosecant answers are both positive here in this situation. The rest of my answers should all be negative. And so that's a nice way to kind of double check your work, right? Make sure you have the right signs for each of your trig functions based on where your triangle was drawn.